So in the video, you saw that it took 3 pyramids to fill up the cube. And so the idea of that situation was 1/3 length times width times height. Here, we have another rectangular prism. And if this is the length, and this is the width, and this is the height, the volume of that rectangular prism would be length times width times height. This one isn't a cube, though. If I found the center of this one, and drew the pyramid there, do you think the same rule is going to hold? Or do you think it would be different because that shape is different? It's going to be the same. And another shape if I call this the radius and this the height, do you remember what the volume for a cylinder is? Has anyone seen that formula before?
Times pi r squared.
Pi r squared times height. So some you probably have seen this before, but an explanation and an understanding of what volume is the space that it holds inside. So if I have that cylinder, it's like, well, how much water could I pour into there? That's kind of an idea of volume. Now, one way to think about volume in this case, and to help you remember this formula, the bottom shape is a circle. If I took a circle out of a piece of paper and I cut it out, and then I took another piece of paper and cut it out and stacked it on top, and another one, another one, another one, and I kept stacking pieces of paper until I got to the very top, the whole thing would be solid paper. It would represent that the whole thing is filled with paper, and what I've actually done is taken all of my circles, which is my bottom, and multiplied it by the height, and that will become the volume. So I find that that helps me remember this formula. I think of a circle and stacking a whole bunch of circles all the way up to the top to help me remember that.
Would a cone work the same way?
So that's the next question. That is where we're going, is if I now connect this to a cone, will it work the same? And the answer is yes. The volume of a cone is 1/3 pi r squared h. And it goes to that same idea. You know how we checked with a square, and then checked with a rectangle, and then we could check with a hexagon, and check with an octagon, and then a 10-sided decagon, and then a 20-sided gon, and a 30-sided gon, and we keep going. And if this 1/3 worked for every single polygon, that idea of continuing it forever means that it also works for a cylinder. So the volume of any right prism, and this is the same idea, and a prism means that the base stays the same and you go straight up. So if we imagine cutting this hexagon out of paper, sticking it down, making another hexagon out of paper and sticking it down, and keep stacking them all the way up, it would fill the whole shape full. And so the volume of any prism, we just need to find the volume of the base, or the area of the base, and multiply that by its height. And any time you have a pyramid, and a right pyramid is where that point is right at the top, right in the middle, the area of the base times the height would be the prism, and the pyramid will always be 1/3 of that. So here's our first example. We've got a pyramid. it has a square base. So if we want to calculate the volume of this pyramid, it will be 1/3 the area of the base, which is going to be 2 times 2 since it's a square, multiplied by the height, which is 7. And if I do this without a calculator, are you okay that 2 times 2 is 4? 4 times 7 is 28. Okay, how do we multiply 28 by 1/3? Okay, if I have 1/3 times by 28, well, I can think of fractions. 28, and how I multiply fractions, 28 is the same as 28 over 1, right? And how do I multiply fractions? Multiply our numerators, multiply our denominators. So we could leave our answer as an improper fraction, and since we're dealing in feet, we'd have feet cubed. Or we could change this to a mixed fraction, 9 1/3 feet cubed.
So, is it given us the slant height or the actual?
Oh! Good eye. I missed that. Okay? See what you noticed? I just saw the dotted line and thought it was the height. So if this 7 went to the middle of that, it would be this answer. But since the 7, if we're looking at it more carefully, which I did not look at it carefully, since it is the slant height, we don't know the actual height. So I'm going to just add, if the height equals 7, then this would be our work. Okay? And then in your notes, we can just put a little line through it so it doesn't like wreck your whole notes. But we do notice that it's not the height that equals 7, but the slant height that equals 7. So how do we find the actual height? Again, it's the slant height that equals 7. Draw the triangle off to the side. Label the height you want to find. We know this is 7. How long will this side be? 1. Because the whole length is 2. This part right here will be half of that, which will be 1. And so we'll do a squared plus b squared equals c squared. We want to find h, which is not the hypotenuse, it's one of the sides. So when we write out 1 squared plus h squared equals 7 squared. 7 squared is 49, 1 squared is 1. Move the 1 over. H is equal to the square root of 48. If you had to do mental math, how would you estimate that? Just under 7, because 49 would be 7. So it seems reasonable to estimate it as just under 7. So square root of 48 is 6.93. Again, I'll put it on my calculator here. Square root of 48 is 6.93. Now, when doing our work, now we can go to our volume formula, and it's exactly the same as before. Area of our base, 2 times 2, multiplied by our height. Now, if I write 6.93 in here, I'm already rounding. So one of the things that we start to do in math is instead of writing 6.93, we start to leave our answers as exact numbers. The exact number instead of 6.93 would just be to leave it as a square root of 48. And so right in here, And since our calculators are smart, our calculator lets us type this whole thing in. So I can go to my calculator, I can go 1/3, and if you have a TI-84 calculator, I want you to check what happens if you go alpha F1. Does this menu come up? If you have a TI-84 and this menu doesn't come up, it means you have an older operating system and I can upgrade it, if you like. Okay? If you have a TI-83, it cannot be upgraded. You just have to settle with what works. If you push enter on n divided by d, it actually lets you type fractions, so I can even type 1/3 exactly as it shows. Times by 2 times 2. Oh, I'm going to impress myself and do a little bit of mental math. Multiplied by the square root of 48. So instead of, and you have to use these arrow keys sometimes to get outside of a function. Instead of writing the 6.93, which is already rounded, by writing the square root of 48, I keep things exact all the way through. Then when I push enter, I know that this answer and all of its decimal places are correct, and I can round this, my volume, to 9.24, include my units, feet cubed.
Wouldn't that be an approximate sign?
And this should be an approximate sign, so I will go back and do that fancy fixer-upper afterwards. How big is a foot cubed? If you look down at the tiles, that's a foot square. So you imagine that foot square, and imagine pulling it exactly 1 foot up and holding a cube that big. So to fill up this pyramid, if you had boxes that big, you need to fill them up 9.24 times and pour them into the pyramid in order to fill up the entire pyramid. Is this pyramid extra huge? Not too bad. Like imagining 9 cubes that would fit in this room. That's not too crazy a size of pyramid. Again, this is the same idea. It's just looking at prisms. So, same rule, because we have a square base, we make a prism. The volume will be 1/3. I would like you to try this one on your own. I would like you to try to draw a picture of it as well. I could have had everything and divide by 3 at the end. That works as well. I was just writing it out exactly as the formula shows to show that you could type it into your calculator the same way that it shows.
Why would the formula
Yes.
Would you accept either way of doing it?
Whether you multiply this all out and divide by 3 or, yeah, because it comes out with the same number, right? So you're knowing that dividing by 3, whether you do it at the beginning or at the end, order of operations doesn't matter, right? We do have to be careful with order of operations if we're adding and dividing, or multiplying and adding, or multiplying and subtracting, because then order of operations is important. But in this case, bed mass would be this. Do you remember bed mass? Bed mass says do dividing before multiplying, right? It could have been Memdas, because multiplying and dividing really don't make a difference. Memdas. Or it could have been, because adding and subtracting doesn't matter either. So we could have had Benmasa. But that doesn't roll as nice off the tip of your tongue, right? Or you could even have Bendisra. It could really make it bad. So the multiplying, dividing, adding, and subtracting could happen either way. Excellent. Okay, now we're going to, as far as our notes go, stop right here for today.